This is a walkthrough for the Edexcel higher tier paper 3 from June 2023. The time allocated for the paper is 1 hour and 30 minutes and a calculator is allowed. In order to benefit the most from this walkthrough, I would recommend that you complete the paper in advance, or alternatively, as we go through the paper, pause the recording, have a go at the question and then play again. Question number 1. Simplify m squared to the power 3. So in this situation where we've got the brackets, we're going to multiply the powers and it's going to give us m to the power 6. Simplify x to the power 5 times x to the power 8. So when we've got this situation where we multiply, we are going to add the powers, which is going to give us x to the power 13. Expanding these brackets, so we're multiplying each of these terms by 4p. That's going to give us 4p to the power 3 plus 4 times 3 is going to give us 12. P times p squared. And there's nothing we can do to collect those together or make it any simpler. Question 2. Johnny wants to know how much coffee he will need for 800 people at a meeting. Each person who drinks coffee will drink 2 cups of coffee. 10.6 grams of coffee is needed for each cup of coffee. Johnny assumes that 68% of the people will drink coffee. Using this assumption, work out the amount of coffee Johnny needs. Give your answer correct to the nearest gram. Okay, so first of all, let's work out how many people he is expecting to drink coffee. So we want to work out 68% of 800 people. And 800, let's use a decimal multiplier, times 0.68. Is going to be 544 people. You can also divide by 100 times by 68. Should give you the same result. So each one of those people is going to drink 2 cups of coffee. So 544 times 2 is going to give us 1,088 cups of coffee. Each person will drink 2 cups and 10.6 grams of coffee is needed for each cup of coffee. So let's work out how many grams of coffee we need. And if we change that to a decimal, that's going to give us 11,532.8 grams. Let's just check the question asks us to give our answer correct to the nearest grams. That's going to be 11,533 grams. Johnny's assumption is wrong. 72% of the people will drink coffee. So Johnny assumed originally that 68% of people will drink coffee. So how does that affect our answer? So we're going to have more people drinking coffee. He will need more coffee. This one, just a 1-mark question, so we don't need to do any further calculations. Question 3. ACF and ADG are straight lines. BCD and EFG here and here are parallel lines. Show that triangle ACD is isosceles. And give a reason for each stage of your working. Okay, so ACD is this triangle up at the top here. So isosceles triangle has two equal sides and, more importantly for this question, two equal angles. So let's start with this angle 125 down here. So I'm going to work out this angle first of all. So 180 minus 125 degrees is going to give us 55 degrees. I'm going to label that on here so it's really clear. This is going to be also, I should describe this angle, so AFG describes this angle. Okay, and that's angles in a straight line and to 180 degrees. Okay, so I'm going to work towards finding out some angles in this triangle. If I next look at this angle, I've got angles in parallel lines here. These two are related, they're corresponding angles. So let's write that down. So angle ACD is equal to angle AFG, and they are corresponding. Going over to this side here, I've got two angles in a straight line. So I know 180 degrees, take away 110 is 70 degrees. 3D C equals 70 degrees. And again, that's angles in a straight line. Next, I can work out this angle up here. So let's add together 55 and 70 degrees. So obviously got a triangle here, so the angles are going to add to 180. If I subtract that from 180 degrees, it's going to give me 55 degrees. So I've got angle, that's CAD, is equal to 55 degrees. And we've got angles in a triangle and to 180 degrees. Okay, the first thing I need to state is just obviously we've got these two angles that are equal. So this triangle is isosceles. So ACD equals CAD, and therefore the triangle ACD is isosceles. Question 4. It takes 14 hours for 5 identical pumps to fill a water tank. How many hours would it take 4 of these pumps to fill another water tank of the same size? So we've got 5 pumps and 14 hours. The key to these questions are to scale it. Let's have a think about how long one pump would take. So you might want to divide by 5, but in this case, one pump working on its own, it's going to take 5 times longer. So 14 times 5, if you've just got one pump, would take 70 hours. Okay. In fact, we've got 4 pumps, so that's going to be 4 times faster. So that's going to give us 70 divided by 4, which is going to be 17.5 hours. Obviously, the assumption there is that all these pumps are working at the same rate. A and B are numbers such that A is equal to 2 squared times 3 to the power of 4. I'm just going to break this up. times 7, and B is 3 squared times 7 squared. Okay, we've got to find the highest common factor of A and B. So they've set this question up so that we can use the Venn diagram method to organise our thoughts. Make sure the overlap is big enough. So if we've got A here, B here. So first of all, we usually start with the intersection in any Venn diagram question. So let's see what's common to both of them. So we've got no 2's, but we've got 2 3's. So 2 3's, let's stay organised. Cross those off. We've also got 1 7. That's common to both of them. For A, we've got an additional 2 2's and 2 3's. Make that more like a 7. And then we've got 7 in B. To find out the highest common factor, what we're looking at is this intersection. What I do is I take these 3 numbers and I multiply them together. So 3 times 3 times 7 is 63. To find the lowest common multiple of A and B, I've done a lot of the work, so I can use this Venn diagram again. This time, the lowest common multiple is all the numbers multiplied. So 2 times 2 times 3 times 3 times 3 times 3 times 7 times 7. So basically what that's doing is eliminating any repeats in the process. So put that into the calculator. That gives us an answer of 15,876. Question 6. Lava flows from a volcano at a constant rate of 11.9 meters cubed per second. How many days does it take for 67,205,600 meters cubed of lava to flow from the volcano? And we need to give our answer correct to the nearest day. So first of all, let's work out how many seconds is it going to take for all that lava to flow out. So if we take our total amount of lava and divide it by how much is flowing per second, that should tell us. It's going to give us total time around about 5 million seconds. So we need to scale that up into days rather. We'll do it step by step. So if we divide that by 60, that's going to change it into minutes. Look at this. Around 94,000. Just going to keep my units there, just keep track of what I'm doing. Let's change it to hours now, so 60 minutes in an hour. And then, this isn't it. Finally, we're going to change it into days. So if we divide that by 24, we get 65.36. We need to give our answer correct to the nearest day. So it's going to be approximately 65 days. Question 7. Here is the graph of y equals x squared minus 2x minus 2. We need to write down the coordinates of the turning point of this graph. So this is the same equation. So it's worth double checking. The turning point is going to be here at this minimum point. So if we read off, we can see the x coordinate there is going to be 1 and the y coordinate -3. Part B. Write down an estimate for one of the roots of x squared minus 2x minus 2 equals 0. So We've got where it's equal to 0. This is the point where y is equal to 0, which is where it crosses the x-axis. You can see there is actually two solutions, so we can choose either one of those solutions. If we read that off, we can see that x is going to equal 2.7, or alternatively, you could have the negative root, which is negative 0.7. You only need one of these solutions for the one mark. Question 8. A solid cuboid is made of metal. The metal has a density of 9 grams per centimetre cubed, and the volume of the cuboid is 72 centimetres cubed. Work out the mass of the cuboid. So we need our formula that's linking density, mass, and volume. So if we put that into the triangle, we've got mass on the top, density on the volume. We want to work out mass. So if we cover up the mass, we've got density times volume. So it's worth just checking that the units are consistent, because sometimes it will require you to do a conversion. So we've got grams, centimetres cubed, and grams. So that's fine. We don't need to do any adjusting there. We're just going to go ahead and multiply these two numbers, which is going to give us a mass of 648 grams. Question 9. Some people were asked if they wanted a new television. 70% of the people said yes, and 80% of the people who said yes wanted a television with a large screen. What percentage of the people asked said they wanted a television with a large screen? So what we want to think about is 80% of that 70%. So 80% as a multiplier, 0.8 times 70%, give us 56% of the total. Question 10. ABC or ABD is a triangle. C is a point on BC. We need to work out the length of BC and give our answer correct for one decimal place. Right, so we've got a right angle triangle here. So when we have a right angle triangle, we can use either SOHCAHTOA or Pythagoras. We have an angle involved, so we're going to use SOHCAHTOA. If we've got two triangles, it's a good indication that there's going to be two steps to the workings. So in order to work out DC, in fact, we do need another length within this triangle on the left. So we're going to have to work out AC first of all. So let's have a little look at this triangle on the right. So we've got the angle here, 41 degrees. What we want to think about first of all are what sides have we got involved. So this AC is opposite the angle, and 6.8 is going to be our hypotenuse. So we need to use sine. So let's have a look. So we've got sine of our angle, 41 degrees. It's going to be equal to my opposite side, which I'm going to just call AC, divided by the hypotenuse, 6.8. In order to solve that, I'm going to multiply by 6.8. So AC is going to be 6.8 times sine 41. You might also find it helpful to do a little triangle to rearrange the equation. So I've got sine 41 here. I've got AC as my opposite side and my hypotenuse 6.8. So if I cover that one up, I can see that I need to multiply those two to work out AC. So put that into the calculator. It's going to give me a length of 4.46 centimeters. I want the final answer to be correct to 1 decimal place. I'm going to work to 2 decimal places, just make sure I don't lose any of those accuracy marks. So I know that this side here, AC, is 4.46. So now I can work out BC. Okay, so again, let's have a think about which sides we've got involved. I'm going to change colours here. So DC is next to the angle, isn't it, or adjacent? And this side over here, conveniently, is going to be my opposite side again. So this time, I want to use tan. I've got, so tan of my angle, 55 degrees. It's going to be equal to opposite, which is 4.46 divided by DC. Okay, in order to work out DC, I'm going to need to divide 4.46 by tan 55. So multiply by DC, divide by tan 55. And that's going to give a length of 3.1 decimal place. Question 11. The table shows some information about the heights of a group of adults. The least height, 169 centimeters, greatest height, 186, median, 177, lower quartile, 174, and the upper quartile, 180 centimeters. On a grid, we've got to draw a box plot for the information in the table. So we're given all the values that we need here. We don't need to calculate any of them. And we've got a little model of what our box plot should look like. So obviously this is the lowest value, lower quartile, median, upper quartile, and the highest value. I'm going to draw it. It doesn't really matter what height you draw it out. I'm going to draw it with the same scale. So sort of 2 above and 2 below this central line. Okay, so we've got, just be a little bit careful here with the scale. I've got 10 squares is worth 5 centimeters. So each one is going to be 2 on this scale. So my 169 is going to be 2 before 170 line. And my highest value 186, so that's going to be over here. Median 177, so 177, so 174. And 180. Okay, and then I join these central 3 into a box, and then I've got my 2 whiskers on the outside. So now I've got my information in the box plot. Part B is asking to compare the distribution of the heights of the adults with the distribution of the heights of the teenagers. So this, whenever you get a question when you need to compare distributions, there's 2 marks allocated here. Really important that you don't end up just saying the same thing twice. So you want to, first of all, compare the median values. So let's have a look. The median value for the adults is 174. Median value for the teenagers is going to be 169, isn't it? So we can see the median heights for the adults is greater than the teenagers. So there's no need to quote figures here, we just need to say which is greater. Also, for these marks, at least one of your comparisons need to be in the context of the question. So it needs to mention height or needs to mention centimeters. Okay. For the other mark, you can either compare the range or the interquartile range. So if I look here, my interquartile range is going to be 180 take away 174, so it's going to be 6. This one here is going to be 171 take away 165, so is also going to be 6, isn't it? So part 2, the interquartile range, or IQR, is the same for both adults and teenagers. Question 12. Show that x minus 1 times x plus 3 times x minus 5 can be written in this form, where a, b, c, and d are integers. So just a reminder, integers, whole numbers, they can be positive or negative, so they don't necessarily all have to be plus terms. Okay, key to this question is stay quite organized. Let's multiply out. Well, you may well have multiplied any 2 of the brackets together. That's absolutely fine. You can start with any of them. I'm just going to start with the first 2. So FOIL is a popular method of multiplying out. You might also do a grid. We've got x squared plus 3x minus 1x minus 3. And let's just tidy that up before we multiply it any further. So we've got, collect these 2 centre terms together. So we've got x squared plus 2x minus 3. Okay. So I multiplied my first 2 brackets. So I just need to multiply this result by x minus 5. So x minus 5 times x squared plus 2x minus 3. Okay, the key here is we need to multiply every one of these by every one in this second bracket. I think it's a little bit easier if we split it up into x times this bracket and then minus 5 times the bracket. Find it a little easier just not to miss any of those terms out. Okay, and then we'll collect these all together at the end. So we've got here x cubed plus basically the power of x is increasing by 1, isn't it, for all of these terms. So 2x squared minus 3x. And then when we multiply these ones, we're going to get minus 5x squared and x, and then changing the sign of all of these because we're multiplying by a negative here, so negative times a negative, that's going to give us positive 15. Okay, and then if we collect together all these terms, so we've got only one cubed term, 2 squared terms here, so overall we're going to get minus 3x squared minus 3 minus another 10x is going to give us minus 13x, and then plus 15. An expression for the nth term of the sequence of triangle numbers is n times n plus 1 over 2. Prove that the sum of any 2 consecutive triangle numbers is a square number. So consecutive numbers are next to each other. So let's just have a little think about if we just have numbers. So if we start with n, the consecutive numbers would be n plus 1, the next number n plus 2, n plus 3, and so on. Okay, so the first triangular number is obviously n times n plus 1 over 2. If we're going to think about the next, and we're going to think about the sum of them as well. So the next triangular number, so if we add 1 to n, we're going to get n plus 1. And if we add 1 to n plus 1 here, we're going to get n plus 3. And this is going to be divided by 2 still. Okay, so I want to simplify this. Hopefully I'm going to get something that will appear at the end that is a square number. Okay, so if we write these, so they're both as a fraction over 2, aren't they? So I can actually just combine my numerators. So n plus 1 plus n plus 1 times n plus 2 all over 2. Okay, so this doesn't really tell me a lot. I can factorize though, can't I? So I can see here that n plus 1 is going to be a factor of both of these terms. So what does that leave me with? If I factorize n plus 1 up here, I'm going to get n, and then this second term, 1 plus 2. And this is still divided by 2. If I simplify this further, I'm going to get n plus 1, and this is going to give me 2n plus 2 simplified. I can factorize a 2 out of this second bracket. So for n plus 1 times 2n plus 2, still divided by 2. And then I can cancel here. Oh, that should be second. That should be, once I factorize that 2, that should be also n plus 1. Okay, which is going to give me n plus 1 squared. Okay. And then I ran out of space down there, but a little conclusion would be good. N plus 1 squared is a square number. Okay. You might have simplified this in a slightly different way. So you can just multiply out these brackets here to get n squared plus n plus n squared plus 3n plus 2. And if you simplify that, you can factorize it as well to get back to this same result. So you may have gone about it in a different way, but still come to this end result. Question 14. OAB is the triangle. Yeah. OBC is a sector of a circle centre. Oh, we've got to calculate the area of OBC. Okay, so we need to give our answer correct to 3 significant figures. So OBC here is part of a circle, isn't it? We've got a sector. So what we need to do is think about the fraction, so theta over 360 times the area of the circle times pi r squared. Okay, so we know here we've got the angle, haven't we? But what we really need to do is work out what is the radius. Okay, so obviously we've got another triangle over here. There's some indication that we need to do a further calculation to work it out. So we've got a triangle here. It's not right angled this time, so we can't use SOHCAHTOA. We can't use Pythagoras to work it out. We're going to have to go to our non-right angle trig. Okay, these formulas you can find on the formula sheet. We can use the sine rule or the cosine rule. Okay, sine rule usually, always involves pairs of angles and sides. Cosine rule is what we're going to use in this case because we know 2 sides. We want to work out a third side over here. This is the radius, and we know 1 angle. Okay, so we can use the form of the cosine rule that we're given. So a squared plus b squared plus c squared minus 2bc cos a. Okay, really important here. We've got a is opposite this angle a. Okay, so a squared is going to be, it doesn't matter which of these sides we're using for b and c, they both play the same role in this. So I'm going to use b is 9 and c is 6. 2 times 9 6, and then cos 85. Okay, pop that all in the calculator. No real need to simplify every term individually. It's going to give me a squared is 28.53. Don't forget to square root. This point, so square root. It's going to give me 5.34. I want my end answer to be correct to 3 significant figures. So always good practice just to any values that I'm using in the interim, just to round them to 4 or more significant figures. Okay, so I've worked out A, which is actually my radius, isn't it? So we've got the radius is 5.341 centimeters. I've got my angle is 80. So we pop those into the formula, we're going to have 80 over 360 times pi times 5.341 squared. And that gives me 19.9187, so 19.9, and I round it to 3. Significant figures. Question 15. Part A. Factorize a squared minus b squared. So we've got two squared terms here with a subtract in the middle. This is going to be the difference of two squares. Always good to be able to spot these ones. And what we do is we square root the first term, we square root the second term, and one of my brackets is going to be a plus, and one of them is going to be a minus. So a plus b, b minus b. Part B, show that 2 to the power 40 minus 1 is the product of two consecutive odd numbers. So you might think it's quite confusing, but if we look at what we've done above, there's a big hint in part A. So it's the difference. 1 is a square number. If we think about it, 2 to the power 20, if we square that, we're going to get 2 to the power 40. Okay, so it's basically, so it's quite a complicated looking example of the difference of two squares. So if we break that down in the same way, we're going to have 2 to the power 20. Obviously, if we square root 1, we get 1, and it's going to be plus 1 and minus 1. Okay. So we need to show that really that's not quite enough to show that it's the product of two consecutive odd numbers. So obviously 2 to the power 20 is even. So 2 to the power 20 plus 1 and 2 to the power 20 minus 1 are odd numbers. I probably should say there as well, they're consecutive. Question 16. On the grid, enlarge triangle T by scale factor -2, where centre of enlargement -2, -2. So let's first of all mark the centre -2, -2. When we're enlarging the scale factor -2, what's going to happen is all our distances are going to be twice as far from this centre, but they're going to also be in the opposite direction. So my shape is going to end up twice as big, but sort of upside down over here. Okay, so let's work out where these points are going to go. So let's have a look. Let's go to this point at the top first. So it's going to be 1, 2, 3, 4 to the left. So I'm going to multiply that by -2. That's going to take me 8 right. So 2, 4, 6, 8. So it's going to be my image of that top point. Okay, let's go to this point next. Okay, so doing the same thing. I'm going to go 1, 2, so 3 left and 3 down. So if I do the opposite from the center, I'm going to go 6 right and then 6 up. So 2, 4, 6, and 2, 4, 6. Okay. If I do the same, well, either I can think, oh, this point, or the side of the triangle is 2 units long to the left, so it's going to be 4 units long here in this direction. You can also count out to this point as well. So your image should be here. In order to check your answer, you can also draw in rays through the center. So if you go through the center, you should hit the image of each of these points. So that's a nice little check that you can do. That one needs to go in horizontally along here. Question 17. Here is a distance time graph. Find an estimate of the gradient of the graph at time 2.5 seconds. You must show how you got your answer. So what we're going to do if we want to work out an estimate of the gradient is we're going to draw a tangent at this point. So your tangent wants to have roughly the same gradient as your curve. You need to have no air between. So if there's a gap between where you've drawn your tangent and the curve, then redraw that one. Okay. And then what we need to do is when we think about the gradient, we want to work out the change in the y, or in the vertical distance, divided by change in the x direction. In this case, it's the time, isn't it? So let's draw in our little triangles. So I'm gonna draw it in so that my horizontal distance is going to be 1. Should be a little bit easier then to hopefully calculate with. Okay, so if we look what the change in the y direction is, got quite a condensed scale here, so that's going to be 14, and this one here is going to be 30. So 30 minus 14, that's going to be 16. And this horizontal distance, I'm going to divide by 1. So my gradient there is going to be 16. What does the gradient of the graph here represent? So the gradient is, the change in y here is going to be the change in the distance, and we're going to divide that by time, so that is going to give us the speed. Question 18. A solid frustum is made by removing a small cone from a large cone, as shown in the diagram. The slant height of a small cone is 6, slant height of the large cone is 10. The radius of the base of the large cone is 3. And we're going to calculate the total surface area of the frustum. We're given the formula over here. So the curved surface area of the cone is going to be pi times the radius times L. And L is this slant length that we're given. What we could do with doing is, before we start working out the radius here of this, well, the top of the frustum or the base of the smaller cone. Okay, so if you look at these ones, they're going to be similar triangles. So our scale factor here is going to be 10 over 6, which is 5 over 3. Okay, so that's obviously to go from the small triangle, isn't it, to the big triangle. So if we want to work out the radius of the smaller triangle here, the base, then I'm going to divide by 5 over 3, which is going to give me 1.8 centimeters. Okay, so let's have a think about how we're going to work out the surface area. So there's a few parts, isn't there? There's going to be the base, which is a circle, isn't it? Then we've got the top of this shape, which is a smaller circle, and then we've got the curved surface area of the large cone. But then we're going to subtract the curved surface area of the smaller cone. Okay, so let's think about what they are one by one. So the base is the circle, isn't it, with radius 3, so that's going to be pi times 3 squared. Okay, the top circle radius 1.8, so that's going to be pi times 1.8 squared. The full surface area of the large cone, so it's going to be pi times r times l, isn't it? So the radius is 3 and the length is 10. And then from that, we want to subtract the smaller curved surface areas. It's going to be pi times the radius of the small one is 1.8 times L for the small one is going to be 6. So pop that into the calculator. I can type that all in together or work it out separately, however you feel confident. That's going to give me a solution of 98.77. I want to write it correct to 3 significant figures, so it's going to be 98.8. It's going to be meters squared to 3 significant figures. Question 19. Sana needs to draw the graph of y equals 3 to the power x for 0 to 4. She draws the graph shown on the grid. And we want to figure out one thing that she's done wrong. So it's always worth checking the axes. So are the scales equal? Which they are. Are the points plotted correctly? So for example, 3 to the power 4 is 81. So 4, 81. 3 to the power 3, 27. That's correctly plotted. 3 to the power 2 is 9. 3 to the power 1 is 3. The problem here with this graph is 3 to the power 0. So anything to the power 0 is going to give us 1, isn't it? So this should be at 0, 1 rather than 0, 0. Okay. The exponential graph should never touch the x-axis. Question 20. Prove algebraically that 0.123 recurring can be written as 61 over 495. So this is going to be 0.1. So the 2, 3 is going to be the recurring part. So it's 2, 3, 2, 3, 2, 3. Okay, so process to do this. So let x equal 0.123. The process here, we need to line up our recurring 2 3s so that we can subtract them from each other. That gets, obviously, we'll turn it into a nice round fraction. Okay, so powers of 10 are the key to this. So let's have a look. 10x is going to be 1.232323. So this is not going to be our solution. Let's think about 100x. It's going to give us 12.3232. So our recurring part's not lined up yet. So let's think about 1000x. That's going to be 123.23. So on. So the 2 that I'm interested in are these 2. So you can see if I subtract one of these from the other, it's going to get rid of everything after the decimal place. Okay, so it's always good to stay organized. I'm going to rewrite this. So 1000x is going to be 123.23. And 10x is going to be 1.23. And if I subtract these on my left hand side, I'm going to get 990x. And on the right hand side, I'm going to get 122. If I rearrange that, I'm going to get x is 122 over 990. So let's have a look what I'm aiming for. So I can see that if I half each of those, I'm going to get to the answer there. So it's going to be 61 over 495. Question 21. Solve this equation. So for my first step, I want to get rid of these two denominators. So I'm going to multiply the whole thing by x plus 4 and 2 minus 2x. Okay, so for my first term, my x plus 4 is going to cancel. I'm going to get 2 minus 2x. And second term here, so this bracket here is going to cancel. I'm going to get 3 lots of x plus 4. And on the right hand side, I'm going to get x plus 4 times 2 minus 2x. Okay, so you can see when I multiply this out, I'm going to get a quadratic. So I want to collect together my terms and rearrange it so it's equal to 0. So let's multiply out. Don't try and do too much in one step. So 3x plus 12 is going to be equal to 2x minus 2x squared plus 8 minus 8x. Let's collect together the terms on the left and the right. So here I'm going to get x plus 14. And here I can collect together my x terms as well. So I'll get minus 6x minus 2x squared plus 8. Okay. I'm going to move my terms over to this side. I want my x squared to be positive. It's easier to factorize. So 2x squared, x plus 6x, it's going to be 7x, and 14, subtract 8. It's going to give me plus 6, and that's equal to 0. Okay, so now I can factorize. Well, I can try to factorize. Obviously, if I can't factorize it, I can use the quadratic formula to solve it. So, two brackets. These are both plus, so I know at the beginning of one I've got 2x. At the beginning of the other brackets, it's going to be x, and they're both going to be plus. My factors of 6, I've got 6 and 1, or 2 and 3. I want to make 7x. If we think about these pairs, so 2 times 2 is going to give me 4x here, and if I put the 3 here, it's going to give me plus 3x. So overall, that would give me 2x squared plus 7x plus 6. You may also use a different method. There's a number of different methods that we can use to factorize these. Another that I quite like, so if we're factorizing this, you know, a times b is going to give us 2 times 6 is going to give us 12. And a plus b is going to give us 7. So I'm going to use the grid method to factorize this. Okay, so I've got two things that multiply to give me 12, two things that are going to add to give me 7, so that's going to be 3 and 4. So I put my x squared term in here, so 2x squared. This is going to be 3x, 4x. So I've broken up that x term. You might use another method that's very similar, and then my number is going to be 6. And what I'm going to do is work backwards. So I'm going to work out what's the common factor to both of these. So that's going to be 2x, working up this first column. So 3x and 6, that's going to give me 3. You can probably see this is linking to my brackets here. And then if I work along here, I'm going to get x. And it's the highest factor of these 2. So it's another quite nice method for finding out your brackets. Okay, the last step is Once I've got those brackets equal to 0, I just need to solve them. So 2x plus 3 is equal to 0, 2x is equal to minus 3, and x is equal to minus 3 over 2. For the second bracket, x plus 2 equals 0, x is equal to minus 2. Okay, so let's just be clear which are our solutions. So x is going to be equal to 2, or x equals minus 3 over 2. Question 22. Given that the vector a times 2, 6 plus b times 8, 2 is parallel to the vector 13, 6. But find an expression for b in terms of a. Okay, so let's just start to multiply this out. So if we're going to multiply a vector by a, that's just going to give us the vector 2a, 6a. And if we multiply by b, it's going to give us 8b, 2b. And that's equal to, so it's parallel, so it's going to be some multiple. We'll use lambda here. You can use any letter really that you want. 13, 6. Okay, so let's turn this into, so if we compare the x and the y components here, we're going to have 2a plus 8b is equal to 13 lambda. And the second equation, 6a plus 2b is equal to 6 lambda. Okay. Before we can solve this, what I'm going to do is I'm going to make lambda the subject. So for this first one, it's going to be 2a plus 8b divided by 13 if I rearrange it. And for the second one, lambda is going to be equal to 6a plus 2b divided by 6. Okay. I know that lambda is going to be the same, isn't it, for both of these? So therefore, what I can do is put them both equal to each other. So 2a plus 8b over 13 is going to be equal to 6a plus 2b over, oh, that should be a 6. Okay, so I'm going to cross multiply to solve this. So 6 lots of 2a plus 8b. I'm getting closer now to my solution. So 13 lots of 6a plus 2b. I'm just multiplying these out. So 12a plus 48b is going to be equal to 78a 26b. And then I want an expression for b in terms of a. So let's collect together the a and the b terms. So I'm going to take my a terms over here. So if we subtract 12a, I'm going to get 66a over here. 48b minus 26b is going to give me 22b. And then if I divide by 22, I'm going to get b is equal to 3. Question 23. The circle has equation x squared plus y squared equals 25. So the general equation of a circle is x squared plus y squared equals r squared. So we know that r in this case is 5. It's always worth doing a little sketch as well. So let's draw out just a tiny little sketch just to help us think about this. So 25 minus 5. So the point P with coordinates minus 3, 4. So minus 3, 4 is going to be somewhere here, isn't it? So minus 3 and 4 here. Lies on the circle. Alex says that the tangent to the circle at P, so that should be touching the circle at that point P, crosses the x-axis at the point negative 8, 0. Is Alex correct? You must show how you get your answer. Okay, so let's have think about. So first of all, what we need to do is we need to really, in order to work out the straight line that is the tangent, we need to work out what the gradient is. We've got the point, we need the gradient. So let's think about first of all, the gradient of the radius. So we've got a triangle here, haven't we? We want the change in the y, which is going to be -4, isn't it? It's going down 4, divided by the change in the x direction. So that's going to be 3. The gradient of the tangent, so the tangent is going to be perpendicular to this radius. That's a key fact you need to remember. So when we've got a gradient of a line m, the perpendicular gradient is -1/m, so the negative reciprocal. So the gradient of the tangent, therefore, is going to be, so we'll flip the fraction, change the sign, it's going to be 3/4. Okay, so it's a straight line, the tangent, so we know it's going to be of the form y equals mx plus c. And we know that m is going to be 3/4. We could do with working out the value of c, so let's substitute in our point. So our point is -3, 4. That's the x coordinate and the y coordinate. So if we substitute those in, we're going to have 4 is equal to 3/4 times -3 plus c. And we need to rearrange that. And that should give us c is equal to 25/4. Okay, so let's put that all back together. So the equation of the tangent is going to be y equals 3/4 x plus 25/4. Okay, so let's just go back and read the question. So Alex says that the tangent to the circle at P crosses the x-axis at the point -8, 0. Okay, so it crosses the x-axis when y equals 0. So let's put this equal to 0. So therefore, we've got 3/4 x plus 25/4 is equal to 0. Let's rearrange that. So we're going to have 3/4 x is going to be equal to x. -25/4 and multiply by 4. 3x is -24. And x is going to be equal to -25/3. Okay. The question asks us, does it cross at -8, 0? So the answer is going to be no. So for a conclusion, crosses the x-axis to 25/3, 0. Question 24. There is a total of y counters in a box. There are x pink counters, 5 blue counters, and some green counters. The ratio of x to y is 1:3, so that tells us that y is going to be equal to 3x. Frida takes at random 2 counters from the box. Find in terms of x an expression for the probability that Frida takes 2 counters of the same colour. Give your answer as a fraction in the form ax² plus bx plus c over dx² plus dx, where a, b, c, d, and e are integers. Okay, so let's just have a little bit of a think about, we've got 3 colours counters, haven't we? And we need to think about the probability of pink, pink, blue, blue, or green, green. So let's get organised. So we've got the total counters in the box is y, isn't it? which we know is equal to 3x. So if we can put them all in terms of x, that would be useful. So we've got blue counters, we know there's 5. We know that pink, we have x counters. So if we think about the green counters, we don't know, but we do know there's a total of 3x. And if we take away the pink and we take away the blue, that will leave us with how many green we have. So that's going to be simplified to 2x minus 5. Okay, so let's have a think about our probability. So the probability, first of all, let's do pink and then pink. Okay, so the probability of my first pink, I've got x out of a total of 3x I'm choosing from in that box. So for my second choice, I've already taken one pink out, so I've got a remaining x minus 1 pinks left. But also I've taken one out of the total, so it's going to be 3x minus 1 on the denominator. So I can put that together. It's going to be x times x minus 1 over 3x minus 1. Let's think about the probability now. Blue and then blue. So we're not bobbing x, a little bit more straightforward. So it's going to be 5 over 3x for the first choice times 4 over 3x minus 1, which is going to simplify to 20 over 3x minus 1. And then we want the probability of green and then green, which is going to give us 2x minus 5 for the first choice over 3x. And then if I take out one of those, I'm going to have 2x minus 6 choices over 3x minus 1. That's going to give us 2x minus 5, 2x minus 6 divided by 3x minus 1. Okay, so I want the probability of this or this or this, so I'm going to add them together. They have the same denominator, so that's going to be a little bit easier, but I'm just going to have to tidy up then the numerator. So I'm just going to scroll down so I have more space. Okay, so let's add these all together. And we can write it over one denominator. So I'm going to have x plus 1 plus 20 plus 2x, that should be minus. X minus 5, 2x minus 6, and that's divided by 3x minus 1. Okay, let's simplify. Go down to the next line. So it's going to be x squared plus x plus 20 plus 4x squared minus 12x minus 10x plus 30. And if we multiply out the denominator as well, I'm going to get 9x squared minus 3x. Okay, so let's select all these together. So my x squared terms, 5x squared. And then my x terms, so I've got hang on a minute, I've copied that one wrong, I've just realized. So this is x minus 1. So this should be x minus 1. This should also be a minus here. Okay, so let's have a look. I've got 5x squared minus 12x minus 10x minus another x. That's going to give me minus 23x My number terms, I've got plus 20 plus 30, that's going to give me plus 50 divided by 9x squared minus 3x. Let's just check that's in the correct form that we wanted in. So we've got a quadratic on the top and a squared term and an x squared, and an x term rather, on the denominator there. Okay, thank you for listening. That's the final question. Good luck in your exams.